So this is AQA GCSE Chemistry. It's dual award and is also part of the triple award exam too. This is part 2 of the atomic structure topic. In this video, we're going to look at balancing equations, and we're also going to look at the law of conservation of mass. I'm going to recommend that you pause the video as you go, try the activities. There will be a slight gap for you to pause, and then you get a chance to review, see what's gone well, see what you need to work on. So let's look at what we're hoping to see in here, knowing what happens to atoms in a chemical reaction, knowing how the mass of reactants compares to products, know why there can appear to be a loss or gain of mass during a chemical reaction, and the big one that's going to take up most of the video, writing balanced symbol equations, including state symbols, which I will talk about briefly but will develop in later topics to represent reactions. So we're going to look at some worked examples to begin of balancing equations, and you can see here that hydrogen reacts with chlorine to make hydrochloric acid. Now, you are going to need to know by the end of the course that hydrogen and chlorine are diatomic. They exist in pairs. And you will need to know the formula of hydrochloric acid is HCl. When we're balancing, we can't change the numbers within the compounds. H2 has to stay as H2, Cl2 has to stay as Cl2, and HCl has to stay as HCl. All we can do is change big numbers in front. So there's our equation to begin. And you can see that I've got 2 hydrogens and 2 chlorines on the left, but only 1 hydrogen and 1 chlorine on the right. Well, that's really easily fixed. We add a 2 in front of the HCl. We now have 2 of each, both sides. On to the next example. And we've got here butane, C4H10. And we are combusting it with oxygen. So we can see in the first example that it is not balanced. I've got 4 carbons on the left, 1 on the right, 10 hydrogens on the left, 2 on the right, 2 oxygens on the left, and 3 on the right. So let's have a look at how we can balance it. Well, first of all, I'm going to balance my carbons. I've got 4 CO2. I need that to get my 4 carbons on both sides. I then also need my 5 H2O because I've now got 10 hydrogens to match my 10 hydrogens. And I'm just going to put this over on the left hand side to see it bigger because we still have the oxygens to balance. I've now got 4 times 2, that's 8 oxygens here, and another 5 oxygens in water. Now that means I've got 13 oxygens on the right hand side. I need 13 on the left. So what do I multiply 2 by to get to 13? And the correct answer is 6.5 O2, and it is entirely reasonable to have half numbers, as you may or may not see on the examples that are going to follow. So, going to ask you to pause on this section, as with the next sections as well. Have a go at trying to write these out and balancing them, and see how you do. And now you've had a go, let's try and run through them. There are 20 examples here to work through, and they do get potentially a little bit more complicated. So on the first one, I am going to start by looking at the sodiums, and I can see that I've got 3 on the left, so I need 3 NaOH on the right. The problem is that I've now not got the correct balance of oxygens or hydrogens. I'm going to fix that by adding a 3 here. And you can also see my K3 has been balanced by my 3K. If I move on to the next one, my magnesium fluoride and lithium carbonate, I can see 2 fluorines on the left. I've only got 1 on the right, so I'm going to put a 2 there. That now balances my 2 lithiums with my Li2, and it's done. On to the next one, P4 plus O2, so phosphorus plus oxygen, going to phosphorus oxide. Well, I'm going to start by balancing my phosphorus. I've got 4 here, I've got 2 here. I need 2 P2O3. But I've not finished because I've now got 6 oxygens on the right. I've only got 3 on the left, so I need 3 O2 there. And then we're going to move on. We're going to look at rubidium nitrate with beryllium fluoride. And the first thing I'm going to balance here is my fluorine, because I've got 2 here. I've now got 2 here. And from there, I can balance my rubidium. 2 on the right means I now need 2 on the left. And then finally, silver nitrate with copper. Well, I'm looking initially at the fact that I've got 2 NO3s, or you could look at them separately. 2 N's, I need 2 N's. 6 O's, I've now got 6 O's. I put those numbers in, but I've now got 2 Ag here, only 1 Ag here, so I need to put a 2 on there. So now pause and have a go at these. And on this one, I'm going to start with the bromine. I've got 4 on the right, 2 on the left, so let's put a 2 there. And similarly, fluorine, I've got 4 on the left, 2 on the right, so let's put a 2 in front of the F2. On the next one, I'm looking at my CN in brackets. It means I've got 2 C's and 2 N's. So I'm going to put 2 HCN on that side. We're actually balanced on that one. You can check through the rest of them to see that all of the other numbers are correct. On to the next one, I've got 3 fluorines. I've only got 1 fluorine on the right, so I need 3 CSF, which means I need 3 CS to balance it. On to the next one, I've got barium sulfide and platinum fluoride, and I am looking at barium fluoride and platinum sulfide being made. So when I work through here, I've got 1BA, 1BA, 1S, 1S, 2 Fs, 2 Fs, 1 PT, 1 PT. It's actually already balanced. We don't need to add any numbers. And on to the next one. This will be a very important equation as we move through future topics. But I can see here I've got 2 N's, so I need 2 NH3 to balance it. I've now got 6 H's, so I need 3 H2 to balance it. 5 more examples for you. And on this one, the one that stands out for me is bromine. I'm going to need 2 NaBr, so I've got 2 Brs to cancel out. And a similar thing with the fluorines, so 2 NaF. On to the next one, it's the chlorine that stands out. I have 1 Cl, I have 2 Cls, so I'm going to put that in. But I've now got 4 H's, notice that they're in both of them, and I've only got 2 H's here, so I need 2 H2O. I've also just balanced my oxygens. There are now 2 on both sides. On to the next one, and I'm looking at a single Br and 3 Brs. I need 2 AlBr3. In fact, sorry, I'm balancing my aluminiums first. Al2, so 2Al, and that then means 6 bromine, so I need 6 KBr. If I need 6 KBr, I then need 3 K2SO4, so I have 6 Ks on both sides. Then on to the next one. We saw an example here with butane. This works in a similar way. I'm going to balance my carbons are balanced. I've got 4 hydrogens, 2 hydrogens, so I need 2 H2O. I've now got 2 plus 2, 4 oxygens. I need 2 O2 to balance it. And then we're going to move on and look at my chlorines in this case. In fact, I tell a lie, I'm looking at the calciums. 3 calciums, 3 calciums. That now means I've got 6 chlorines, which means 6 NaCl are needed. I've got 3 Na to 6 Na, so I need 2 Na3PO4. Have a go at this final lot. And on here, I'm going to balance my chlorines. I've got 2 on each now, and I need to balance the potassiums as a result. On the next one, I'm going to compare my Cls to begin. I've got 3, so I need 3 HCl. I also then need to balance my hydrogens, and I've got 1.5. I can use halves. Remember, we spoke about that in the example. And from there, if you prefer, you could use whole numbers, and it will be 2, 6, 3, and 2. On to the next one, similar to the one we saw on number 10, but I need to balance my nitrogens, I need 2, and then I balance my fluorines, 3. On to the next one, I am comparing my Se, of which I've got 1 here and 2 here, so I need 2 Li2Se, and because I've done that, I need 2 Li2O to make sure I have 4 lithiums on both sides, and I've now got 2 oxygens on both sides. And then, finally, I am looking at my N's. I've got 2 N's. I've only got 1 N. Going to put that in, and actually the rest of it is already balanced. We're going to finish off by taking a look at the conservation of mass. Have a read through, have a think about it, try it, and then review your answers. So the law of conservation of mass is that the total mass of products is equal to the total mass of reactants. So if we heated 100 grams of calcium carbonate and broke it down, we would expect 100 grams of product to be made. However, if we did this on a balance, we'd only find 56 grams. The clue is in the state symbols, and we'll talk a lot more about state symbols later. But S means it's a solid, S a solid, carbon dioxide, G is a gas. Now when you create a gas, it escapes into the air. So we have 56 grams of calcium oxide, but 44 grams of carbon dioxide has escaped, so we can no longer measure it. Have a go at this final example to end the video. And we're seeing here that we started with 64 grams of copper, but we've ended up with 80 grams of copper oxide. Again, bear in mind, this is solid. It's combining with gas in the air. We're bringing gas in to be part of a solid. So the oxygen from the air has combined with the copper. And we can be more specific that if we had 64 grams of copper and the total mass of product is 80, then 16 grams of oxygen has been taken from the air to combine with the copper. That takes us to the end of part 2. Thank you for listening and goodbye.